Thank you everyone for coming. Thank you to the GLA Summit organizers and everyone else involved for making it happen. I love this sort of stuff. So I'm very happy to be presenting again. So yeah, my talk is called Look Ma Now iMac. I'm John Medland. Easiest way to find me is probably on the LabVIEW Discord, which you can get to links to from the G Central website I learned today. So that's fun. Yeah, and if not, I'm on LinkedIn, but I really miss Twitter. LinkedIn hasn't really, doesn't scratch the same itch, but the Discord is the best place. So I'm gonna jump right in. If I get the right mouse thing, there we go. So starting with our giants, our female slide. So this is Timit Gu. She is a computer scientist and advocate for diversity in technology. She's a strong advocate for an ethical and just AI movement. So maybe as AI comes and takes people's jobs, we want to make sure that's a just transition for everyone. And also we don't want to bake in, historical prejudices and other things into our future by putting those in the AI. So she's very good on promoting that movement. She's also got lots of sort of accolades. So yeah, it was the 50 greatest leaders from Fortune, was one of Nature's top 10 people who shaped science in 2021, one of Time's most influential people in 2022. I'm going to drop a load of links right at the end, and there's a great podcast that she's on that is really good. So you should go check that out. And then I'm also going to do a quick plug. So I work for a company called Control Software Solutions. We are a NI Alliance partner and system integrator based in the northwest of England, and we are growing and we are expanding. So we are looking for new LabVIEW developers. I believe we'll have some jobs being posted soon, but if you did want to get in contact, if you are like a CLD or CLA and looking for a hybrid role in the northwest of England, that would be kind of cool if you could drop us a line. Just let us know. So right, enough of that stuff, and on to some background on what I'm talking about. So there was this, was it a meme? Was it a thing on TikTok? I don't know. I'm too old for TikTok legally, so I only hear about it secondhand or third hand. But there was a thing about like men are always thinking about the Roman Empire like more than you think, and at the moment, or for the past couple of years, my Roman Empire has been augmented reality stuff in LabVIEW. It started as like a serious project, but I kind of wanted to have some fun with it. So this is a little bit of test code I wrote like probably about a year and a half ago now, where I've got a webcam and that's picking out this this checkerboard pattern, and then I'm using LabVIEW to render a 3D model of a cow and making it float in front of it. And as you move the camera, the cow's spinning, but it's sort of staying in the same place. I don't know. It's just a little toy example, but it was good fun to put together. And if you want to know more about augmented reality, then I did a talk at GDevCon Europe. So that was last year in September. That was a lot of fun, but that's on YouTube. You can go and check that out. I'm not going to be doing a huge amount on augmented reality in this talk, but I'm just trying to set some of the background. So one of the slides from my talk was describing the sort of augmented reality bits and pieces. So I'm thinking about like it's an input process output type of operation, like lots of other LabVIEW applications that we build, and we're speaking to some input devices, in this case some webcams. We're doing some processing. So in this example, detecting augmented reality markers. You've maybe then trying to estimate some camera information and pose. You've got like a 3D scene that you're trying to infer information and inject into. There's camera calibration stuff. There's all sorts of stuff. This is all augmented reality, but it's not what I'm here to talk about. So that like I really wanted to take what I'd learned and build it into an open source library, because I got all this knowledge and I'd done loads of like stuff, and some of it was commercial, so I couldn't. But like I'd learned stuff, and I thought, wouldn't it be fun to build a nice library with it and share it with the community? And I acknowledged that like basically probably very few people are going to be using AR stuff. I mean, maybe if there was an open source library, lots more people would, but it like, is it useful? Who knows? But I wanted to make it, so I did. That's the joy of open source. Just do what you want, and there you go. But what we do see, if I can get a transition, is that there's actually like some quite useful stuff that would be more broadly useful for people who have to speak to cameras, especially if we know sort of, in my original talk, I missed that there was like this pre-processing step where you probably have to do quite a bit of image manipulation before you finally process it. So if we show that in this idea, and then highlight the other boxes of stuff that you probably want to do, just as a general webcam, do something, display it to the user sort of thing, then it could be more useful. And wouldn't it be great if for certain applications where you were having to use NI iMac and maybe NI Vision, and then have to think about deployment licenses and all sorts of stuff, wouldn't it be great if there was just an open source alternative that could kind of work in a nice performance-y or performant way? And yeah, you know, wouldn't that be fun? So I thought it would be good if I could bear that in mind when I was developing this, developing my library, and also if I like tried to get the community more involved in giving some feedback early on, they could maybe be like, oh, your library would be really useful for me if only it had like this one little feature, and that might be really easy for me to implement, or anyone in the community who can do that to implement. So it'd be good to get that feedback and do it and make it more useful. So I've been bashing away at some code for a while now, and I finally got a sort of a pre-release out. So I just put this up on my GitLab today. So it's not a fancy VIPM or anything, VIPM package. It's just the source code, but I've also included the built binaries, which you'll need. So those binaries are built for 32-bit and 64-bit Windows. Currently only support Windows. I'll explain why in a little bit. So yeah, so those are available. So if people want to go and have a little play with stuff, they can download it. They can put the binaries into the in with the source, and then they can run some of the examples and let me know how they get on. Or, you know, if you don't like it, you can let me know that too. I don't mind. If you think it's useful and want to do something else with it entirely, you can just fork it. I mean, do what you want. I'm distributing it under the unlicensed, which is like probably the most permissive open source license going. It says, you know, I give this software to the community that it may remain copyright free, public domain for all eternity. The only thing I would flag is that I do use some other open source libraries which do have different licensing, but it's a pre-release. You shouldn't be building it into commercial software and having to worry about licensing. So I'll just flag it. But for the time being, go and have some fun with it, please. That would be great. So what does it do at the moment? Well, it's an augmented reality library, but it doesn't have any AR features yet. Like all things, you think, well, I'll just have to put the foundation in, and then I'll be able to like build on top of it, and the foundation won't take too long. But the foundation has taken quite a lot of time. But I think that sort of means that we're at the point where it's like it could be useful for folks. But sadly, if you want to do your dancing cow example, we're not quite there yet. We're not quite there. So, you know, hold your horses, or cows, I guess it would be. Anyway, so we can do webcam capture, and so we can enumerate cameras, which is really handy. So you can actually see what devices are attached, and you get like this like long system ID, which like has the USB hub and all sorts of other information, but it gives it like a sort of unique ID on the system, which in theory should pretty much stay static. Windows might mess around with it, but it does mean you can thanks, Derek, great comment. It does mean that you can in theory sort of like you could write it to a config to always use that camera, and it should, as long as the camera's there, be the same. But I don't know, that will require some testing and whatever. Then you can also create streams and grab images from them, which is like the important thing for getting video from a webcam. So we can do that. We can't control the camera properties yet. We can't do, well, there might be bugs if you try and like open multiple cameras. I haven't really tried it. That was a pretty intense bit of working with Windows like low-level drivers to make that work. So I haven't had the time to fully test it, but hopefully it's yeah, it's good for testing now with normal non-insane C++ Windows people. And then the image operations. So I'm using OpenCV images under the hood, and I'm using lots of the OpenCV library. That's an open source computer vision library, very handy. I found a fun way of integrating that into LabVIEW with external DVRs, which I sort of learnt about or learnt some. They're not really documented. LabVIEW has one example from the GPU toolkit, I think, or some like GPU related stuff, which they shared. And it was Rolf K on the forums, who I'm eternally grateful for, and is always like helping with people doing this like C++ integration with, or C++ integration into LabVIEW. So it's really handy that he's done that. And then I was able to see what he'd done and shared, and then write a nice library around it. So yeah, so it means that whilst we have our images exist in OpenCV, in C++ land as OpenCV, but we can at any point via the EDVR reference that we have to them, like look at the pixels, which is kind of nice. And as long as you're not changing the size of the image, you can also manipulate those pixels as you want, which is kind of cool. So like, one of the reasons why it's taking so long is I'm like, oh, I could just add that. I could just add that. So we can also load and save images to disk, kind of handy when you're doing stuff. Then you've got your basic image type operations: resize, crop, copy, mask, flip, rotate. There's more. You can like compose, sort of put an image in another image. Yeah, so that should cover lots of like people's need for image operations. There's also stuff around like color channels and various things. And generating masks, because for AR I often need to like subtract a background from things, so lots of with mask type stuff. But it just means like that the number of potential operations you can do is great. Oh, I've just seen a comment saying, is this slower than iMac or comparable? Oh yeah, benchmarking, I don't know. So it seems pretty quick, pretty performant. Certainly image operations are pretty much just operations on memory, so as quick as that'll go. We're using C++, so you know, we're able to sort of get as reasonable performance as we can. Garbage collection, reference counting, all that stuff aside, I don't know Rust yet. It's on the to-do list, but I don't know if it'll get us any quicker. Who knows? Yeah, so it's, as far as I can tell, it seems pretty performant with iMac. Well, sorry, yeah, there's a comment here asking, isn't calling DLL slower? That's exactly what iMac is doing underneath the hood. There's I can't think of any particular operations in iMac that wouldn't be through the core library node. So I mean, you know, you're welcome to give it a benchmark if you want to try. Let me know how you get on. That's good. Sorry. Yeah, so just sorry for the little diversion. It's easy to get off track. Right. So let's see what other features we've got. Yeah, so we can also draw some shapes and text, which is really handy when you're like pulling out regions of interest. You can see what you found and stuff. So that's all in there. That's pretty good. And then, yeah, I've worked really hard sort of building this interoperability layer with a couple of different things. So using eDVRs, external DVRs, gives us that like native-ish LabVIEW access through it, like it looks like an array. I've also wrapped a couple of or created a couple of VIs that will take in a pointer address and like convert that to a my type, like this library's image, which means that you can use one of the iMac methods, which is like get a pointer to the iMac data. And that doesn't require NI vision. So if you're just using iMac and not NI vision, you can still do that. Then also I've written a couple of VIs that just help convert from like a U32 array into like an array of bytes that you could pass to a Python node. And that would be the sort of, if you were going to do OpenCV in Python, that would be the format that you'd need the data for Python stuff. And then for C++, there's a huge amount of interoperability layer that goes between LabVIEW and C++. So going from an eDVR reference that you pass to your core library node to a thing that looks like an OpenCV image is just like a single call, and that then also manages the lifetime to ensure that locking and all sorts of other things that an eDVR provides is handled sort of magically. Yeah, then like we're also plugging into the LabVIEW memory manager, so we can allocate LabVIEW memory and hand those objects, or hand that, yeah, I guess they're objects, hand those things back to LabVIEW and say, I made this using your memory allocation, so now you know what to do with it. And yeah, so that's all good. But yeah, that's been a lot of work. I'm out of time already. Do we still need iMac and NI Vision? Yeah. Like, I'm not looking to replace it, so I don't do lots of the stuff that it does. In terms of drawing the output, which is one of the things that LabVIEW is going to be slower at, or this is going to be slower at than iMac, is we don't have a fancy image indicator. Like with all the tools and everything else, that one seems really fancy and really efficient, and I can't do that. The closest we can get is a picture control, and I can optimize drawing to it, but it's still probably not as good. No fancy cameras. If you've got your giggy whatever Basler cam, that's not. We're just talking USB webcams, and like, this isn't designed to do lots of things that NI Vision does. So yeah, sorry. And then NI Vision or iMac also supports multi, like 16-bit and complex, all sorts of other fancy image types. I'm just doing like 1 and 4 channel 8-bit images, so single channel, and then like alpha RGB. Yeah, sorry folks. A quick demo. Let's see if this works. And then, oh, I've got our old thanks. Right. Okay, let's fire up the old LabVIEW, bring that across. Right, yeah, so this is my little thing that's going to speak to my webcam. Let's see if this works. So I've got this is like a 2K webcam. So off that goes. Great. I can't get that resolution. So yeah, hello, that's me doing webcam stuff in LabVIEW. If we enumerate the sources, we can like have, what have we got? We should have the system one as well. Yeah, and then you can see all the formats. Yeah, so you can sort of do all that stuff. That's an unfortunate pause. Right, and then let's just, underneath the hood, this is meant to be a somewhat simple example. So yeah, we can, it's like sort of classes and EDVRs, so it doesn't look too odd to normal LabVIEW type things, hopefully. But yeah, so there's some examples. There's also an example like that just does a bit of image operation stuff. Let's just get rid of you. Go away. Cool. Yeah, so thanks. Any questions? Those are links. I'll drop those in the chat now. Oh, I see. So yes, great. We've got a question from Lewis, is it? Have I tried my library and RT systems? I haven't. So to build for RT, I'd have to support, or like minimally, I'd need to support x86 Linux, built for sort of an open embedded platform or open embedded type target. Exactly what it is a bit tricky. So I don't have the webcam driver written for that at the moment. That's only Windows. I am planning on integrating a video for Linux driver for Linux uses. That would be really cool. ARM support for your small RT devices. Well, I don't know, maybe like the challenge there is just doing lots of build tooling. But yeah, so I'm on the way. Oh, I see Kaval's jumped in with an email. Thanks very much, Kaval. And I'll drop the other links in. And there we go. They haven't copied and pasted very nicely, but you can click on the ones that you want. Yeah, any more questions? Great. Well, I've already overrun by 4 minutes. I'm very sorry. But if you do, oh no, I've only, sorry, just looking at the other question about have I compiled classes into DLLs? No, I'm only doing C++ into a nice binary with a C style interface that I can then hook into from LabVIEW. So my build thing is C++ code built to binary, call with a LabVIEW. Sorry, I'm just going to keep talking. So if people do want to leave and go to the next session, they're very welcome to, but I'm just going to stay on and answer the questions. Does an eDVR and map pointer work in a similar way? An eDVR works very similarly to just a regular DVR. The difference is that whereas the DVR LabVIEW is responsible for the underlying memory management, typically an array. An eDVR is LabVIEW expects something else to be managing that memory, that data, but it like in C++ land, I sort of give LabVIEW information about that data, so LabVIEW can then inspect it and modify it. Essentially, I'm giving LabVIEW a pointer to my data. iMac. has a map pointer node. I don't know if I quite understand what you mean there, Shri, but I'm happy to have a chat. Oh yes, yeah, okay, yeah. I think I know what you mean. Yeah. So with an iMac image reference, you can call get pixel pointer. Yeah. So yeah, that under the hood, iMac is just allocating a big block of memory, and then it shoves in its image data and keeps a metadata on what that data means. Yeah, so I'm doing something very similar, and I provide a mechanism in my library to be, if you call that iMac function, you'll get a pointer that's a memory address. You can then pass that to a function in my library, and it can then copy that memory address into a different image, but it's an image that my library manages, not an image that iMac manages. So it's sort of, it's like it, you can do a copy from it, but it's like a single copy operation. It's not like bringing it to LabVIEW then taking it out. But yeah, they do work very similarly under the hood, I believe. I'm the iMac and OpenCV stuff, so they're like sometimes compatible. And if you do want to do iMac with OpenCV, then there is a NI provided toolkit that helps go between OpenCV matrix types and iMac. So yeah, right. If there's any more questions, thank you anyone who stayed around. Thank you everyone who attended, who's now left. Yeah, I'm looking forward to the rest of this. All the best, everyone. Cheerio.